Welcome everybody. Welcome to Vegas. Everyone surviving Vegas so far? Everyone go to the keynote this morning. Wasn't that pretty cool? Lots of cool stuff being announced. So thanks for coming to our session. This is a session on migrating enterprise messaging to the cloud. My name's Trevor Dyke. I'm a product manager at AWS. With me today is Quinn Easterbrook, who's a senior director of platform engineering at Capital One. So let's get into it. So first I'm going to spend the beginning part of the session just giving a basic introduction to enterprise messaging. Probably most of you are familiar with that, but we're going to go through that as a refresher. Then I'm going to talk about some of the advantages of moving to a hosted messaging service. In particular, I'm going to talk about AWS messaging services, SQS and SNS. Then I'm going to talk about an exciting new feature we announced a couple of weeks ago. Maybe some of you saw that, a FIFO queues, which is a new type of queue that we now support for SQS. After that, Quinn's going to talk about a really interesting use case that Capital One has undertaken to migrate their enterprise messaging middleware to the cloud. So let's start with the basics. Most of you already know this, but let's just start with these fundamentals. What are the drivers for enterprise messaging? So really, historically, messaging has been used for two things. Communication between applications, for example, your inventory application to talk to your ordering application. Modern applications are broken into smaller components and taken to the extreme. This is known as microservices. In both cases, those apps or components need to communicate, and that's where messaging comes into play. Traditionally, this has been through message-oriented middleware. So many of you are familiar with some of these products, MQ type of products, IBM MQ, ActiveMQ, and some of the open source ones like RabbitMQ. So just as a question, show of hands, how many people in the audience are using message-oriented middleware today in their company? Wow, even more than I expected. That's amazing. And of those people that said yes, how many really love managing it and managing that software? Oh. Hey, there's one guy, okay. Okay, you can leave. No, I'm kidding. Great, okay. So again, sticking with the basics, there's two common patterns used in enterprise messaging, message queuing and pub/sub or publish/subscribe. So first of all, in queuing. So in queuing, messages are sent from producers to consumers using message queues. It's an asynchronous model that provides buffering. So this is for messaging from point A to point B, where you have multiple, and you can have multiple producers and consumers, but every consumer only gets one message, or each message is only consumed by one consumer. In the pub/sub model, the messages are broadcast or fanned out to multiple subscribers using a construct called a topic. So it's a point-to-multipoint model. The classic example here is the stock ticker, where you have a stream of stock prices and you have multiple readers that want to access that stream of information, those stock prices. So today we're going to be focusing mainly on the message queuing pattern for messaging. So what are some common use cases of message queues? So first of all, very basic one is just decoupling of application components or microservices. So a typical example here is where you have a front end or a web tier that's creating work, like the ordering application I was speaking about. And you have worker instances that are completing the work. So message queues are a great way to decouple those components. It isolates them. You can scale and manage those tiers separately. And it makes it more resilient to failure versus direct RESTful communication. A second use case is application integration. So very similar, but where you have actually separate applications, not components of an application, that are exchanging information asynchronously. So queues allow the applications to be independent and fault tolerant. Another advantage is it allows those apps to be potentially in different environments. So you might have one application that's a Java application running on a Linux server. And you might have another application that's a .NET application running on a Windows server. A third use case is batch and burst processing. So an example here is one of our customers, Shutterfly, uses SQS to process images. So in batch and burst processing, queues let you be resilient to spikes in traffic, to perform work only as fast as necessary to lower costs. And with queues, you have resiliency of data, so you're never going to lose any data when you're passing between applications. Okay, so those are some of the use cases. We've got a refresher on what messaging is, why we need it. What are some of the common challenges with message-oriented middleware? And from the show of hands earlier, it sounds like I don't need to highlight many of those challenges to you. But firstly, operational overhead. So like any software, there's a lot of overhead to managing it, maintaining it, installing it, maintenance. For example, when you need to upgrade software or install a patch, you might have to take down your messaging service for a period of time, maybe during a low traffic period. But it's a time you have to take down your operations or your business. Secondly, capacity planning. So many businesses have peak periods. For example, the Black Friday we just had last weekend. I'm sure many of you bought many products on Black Friday. I sure did. But that's a peak, and you have to scale your messaging system for that peak. If that's an on-prem messaging system or a system that you've deployed using message-oriented middleware, you have to actually plan for that peak. You might have that peak capacity provisioned for the whole year, even for a peak that only occurs once or twice a year. Thirdly, reliability. Turns out it's actually quite challenging to manage a messaging cluster with high availability and durability. So you need to have that expertise in-house. You need to have a team of messaging experts to run your messaging servers. And fourthly, cost. So I already mentioned you have to provision those servers. There's also going to be load balancers, other infrastructure you're going to need to have in place. That's an added cost, and especially if some of it's not being used all the time. There's also, in some cases, the cost to license software. The licensing might be for 2 or 3 years, and you have to pay that up front. So finally, with cost, there's that team you need to manage a messaging platform. And if that's not a core competency of your company, that might be a team that you could be using to do more interesting things. So what does AWS provide? So we provide some managed messaging services, SQS and SNS. We provide a queue service and a pub sub service. So Amazon Simple Queue Service is a fast, reliable, scalable, fully managed messaging service. It's actually one of the oldest AWS services. We just celebrated our 10-year anniversary of SQS this year. So 2006, it was around the same time as S3 came out. And like most AWS services, it's accessible through a web API, as well as through SDKs in most languages, as well as through an API called JMS, or Java Message Service, which is a very common API you'll see in message-oriented middleware. Amazon Simple Notification Service is likewise a fast, reliable, scalable, fully managed pub sub service. So SNS allows you to use the topic construct I talked about earlier to fan out messages to SQS queues, as well as to HTTP endpoints, Lambda functions, and the same service is actually used to send messages to users through mobile push notifications, SMS, or email. So as I mentioned, today we're focusing on SQS. So what are some of the key features of SQS? So SQS gives you a very persistent message queue, very high availability and durability. It's distributed across multiple availability zones. It's available in every region globally. So as you know, we have 14 regions globally and 38 availability zones. It's available in all those locations. And messages are stored across multiple availability zones. So you'll never lose a message. We have multiple redundant copies of every message. Your messages in your queues are retained up to 14 days. That's a configurable option. You can decide how long you want to retain your messages for in each queue. And it provides nearly unlimited throughput. So it'll just scale as you need. You send us more traffic, we'll scale up. And when you reduce your traffic, we'll scale down. A couple other interesting features. So we have CloudWatch metrics and alerts. So things like the age of the oldest message in the queue and your queue depth. One of the very interesting uses for this is you can use those CloudWatch metrics to scale your consumer fleet. So you can use that in combination with auto-scaling, and you can have auto-scaling policies that will scale up your consumer fleet as your queue gets filled up. We also provide the ability to send natively message payloads of up to 256 kilobytes. And actually using S3, we see customers using this pattern where they send basically a pointer to the message payload in SQS and use S3 to store it. And doing that, you can store up to 5 terabytes. Anything larger than that, we recommend that large truck that you might have seen on the stage this morning. So in terms of message payloads, we also do have an extended client we released last year, a Java extended client. It actually facilitates sending larger messages through S3. Basically just replicates the API. You just pass the message, and if it's larger than 256K, we'll store it in S3 for you. Another way to increase throughput and reduce cost is to use message batching. So SQS supports up to 10 messages at a time in one batch. And that's actually the same cost as sending one message. So if you need to reduce cost, that's a good way to do that. And of course, last but not least, it's very highly secure. Uses the AWS Identity and Access Management features, or IAM, for authentication and security. And we use HTTPS or TLS for connectivity, for secure connectivity. So now another question for the audience. Who still wants to manage their own message-oriented middleware? So with things like SQS and SQS and SNS, the real advantage, and it's really the advantage of AWS cloud services in general, is it allows you to really just focus on your business logic and not on infrastructure. You just write your code, and Amazon SQS handles all the dirty work for you, handles capacity, scaling, deployment, fault tolerance, logging, monitoring, and security. Okay, so that's a basic overview of messaging. I'm sure many of you are familiar with SQS and SNS already. So let's talk about something new, the FIFO queue that we just, or FIFO queues that we just announced last week, or 2 weeks ago, sorry. So if you're familiar with SQS, you'll know that it's really highly scalable. You can scale it to many thousands, tens of thousands of transactions per second. One of the trade-offs for that is ordering and exactly once delivery are not guaranteed. You might actually get duplicates sometimes because we've really distributed that queue across many, many, many servers. So with FIFO queues, you don't have to make that trade-off. We provide strict message ordering. Every message is processed exactly once. And there's a construct within these queues called message groups that allows multiple ordered streams within a single queue. It's essentially the same API as the standard SQS queues that we know and love. There's a couple little nuances and changes that I'll go through in a minute. One important thing to note is currently the FIFO queues are limited to 300 transactions per second. So, and from talking to customers as we were defining this product, we found that most use cases for ordered queues actually have a lower transaction rate. So we feel that that's acceptable. So how does this work? Let's go into some of the details. Let's start with a very simple case. So it's an ordered queue. Your producer sends a message to the queue. Let's say it sends message A, waits for acknowledgement, sends message B, waits for an acknowledgement, sends message C. You're guaranteed that the consumer will get those messages in order. That's kind of obvious, very simple case. It gets more interesting when we talk about message groups. So message groups are multiple ordered streams of messages within a queue. So with FIFO queues, the send message API call that we have with SQS has an additional parameter, which is a message group ID. So when you send a message, you pass that message group ID. It's a string. It can be an empty string if you like. Anything you want, whatever you define. We'll recognize that as a group ID. So let's say, there we go, sorry. So let's say we send message A on group 1. Then I send message X on group 2, followed by message Y on group 2, and then message B on group 1. So now I've got 4 messages in my queue. So what happens on the receive side? What's going to happen is the first consumer is going to make that receive message call. It's going to actually get message A. Message A is then going to be invisible to any other consumers. Likewise, I've got a second consumer that's calling receive message. It's going to get message X, which is the next available message in the queue, from group 2. Now, neither consumer or no other consumers can get message B or message Y until those first messages are finished processing. So that's the ordering capability. So now, my first consumer has finished processing message A. So what happens? Well, the consumer that was processing message A gets message Y from group 2. Okay, so there's actually no affinity between consumers and message groups. The reason for that is it allows you to scale your consumers independently and not have to worry about tying consumers to a specific message group. And strict ordering is always maintained within a group. So likewise, the consumer that was originally processing message X gets message B from group 2. Does that make sense? Yeah? Okay, good. So that's ordering. It's relatively simple, but a few nuances to it. What about deduplication? So it's another great feature. A lot of customers are very excited about this as well. So with FIFO queues, we prevent duplicate messages. So there's a couple of scenarios. So first of all, when you're sending, there's sometimes the case where you might send a message and maybe you don't know if SQS got it yet. You didn't get an acknowledgement back. And in that scenario, we want to avoid a duplicate. So what we let you do is we let you retry that message as many times as you want. And there's actually 2 different options we provide to avoid duplicates. And I'll talk about those in the next couple slides and how those work. But basically, there's a message deduplication ID you can use, or there's content-based deduplication. And either one is useful depending on your use case. OK, so first of all, let's go through an example of dedupe on send. So let's say I'm sending message A. So what I'm going to do when I send message A is I'm going to send an additional parameter with that API call, and it's a message deduplication ID. I can set that to whatever I want. It could be a UU ID or something like that. Let's say in this case I pass a dedupe ID of foo. OK, so let's say the consumer is waiting. It's got a receive message call pending on the queue, and it gets that message immediately. What happens is we have this deduplication buffer. It's not visible to you. It's just something that happens behind the scenes. So we keep basically the dedupe ID of that message A in that deduplication buffer. So now, if something goes wrong, for example, that producer never got the OK back from SQS because there's a network fault or something like that. So we can retry. We can resend that message, same dedupe ID, use dedupe ID foo. SQS recognizes that that message has already been processed and already sent off to a consumer, so it won't create the duplicate. So that's the basic send deduplication. There's also content-based deduplication. So you can also turn on a feature where you don't have to send the dedupe ID. We actually look at the content, your payload. We create a SHA-256 hash of that payload. And then if there's any duplicate of that hash, then we won't create a duplicate. So there's 2 different options there. Different options are useful for different use cases. There are some use cases where you might want to have the same payload in different messages, so you might not want to use content-based deduplication for those use cases. OK, so how about receive deduplication? So, and we call this exactly once processing. So it's not exactly once delivery. You don't always want that because let's say your consumer gets a message and fails and the message is never processed. You want to make sure another consumer can get that message, process it. So SQS will make that message available to another consumer if it isn't completely processed. And the consumer can actually retry on receive as well, just kind of very similar to what I just talked about with retrying on send. So let's talk about how that works. OK, so let's say in this example, I've got 3 messages in my queue, A, B, and C. The consumer sends a receive message request to SQS. And there's an additional parameter that can be sent, which is an attempt ID. So it's my receive attempt ID. So in this case, let's say it's attempt ID equal to bar. So what happens is I request a message. I get message A. And the way SQS works is that message A stays in the queue, but it's invisible to other consumers, so indicated by the gray shading there. But let's say now we have a network failure, and SQS thinks it sent message A to the consumer. But the consumer didn't get the message because there was a network failure. So what happens in this case? Let's say the network now comes back online. So the consumer with these FIFO queues, what the consumer can do is call receive message again with the same attempt ID. So attempt ID equal to bar. And it actually can receive another copy of that message from SQS. So basically, it kind of cuts the visibility timeout short and gives SQS, or gives the consumer another copy of that message. The other option that's available, which is a standard SQS feature, is just to wait for the visibility timeout on that message to expire, and then it will be available for another consumer. So there's a few different options there for dealing with failure and for dealing with duplicates. Okay, so let's talk a bit about pricing. FIFO queues, just like SQS has always been, is pay-as-you-go pricing. So it's a low cost per API request pricing. You pay only for what you use. There's no upfront costs. So FIFO queues are priced at 50 cents per million API requests. It's the same price as SQS standard queues were before we launched FIFO queues. And in conjunction, we've lowered the price of the SQS standard queues to 40 cents per million requests. And as previously, the first million SQS requests per month are free, whether they're FIFO or standard queue requests. Obviously, this is implied, but we will continue to support standard queues. They're very useful for many use cases, and FIFO queues are useful for many use cases. So we'll keep supporting both of those queue types. So one of the most fundamental benefits of the cloud is the ability to shed the low-value, undifferentiated tasks and really increase the speed of your operations. And hosted messaging is something that will help you do that. You can move from upfront expense to variable expense. You can stop guessing at capacity planning. It just scales as you need more capacity. You can remove that complicated infrastructure management. And you can go global in minutes. As I mentioned, SQS is available in every region that we support globally. There's many enterprises already taking advantage of AWS messaging services, both SQS and SNS. Some of them are on this slide. One of them is our good friends at Capital One of the largest banks in the US. And I'd like to introduce Quinn Easterbrook from Capital One, who's going to talk about some of his experiences migrating from an on-prem message-oriented middleware solution to hosted messaging services on AWS. Take it away, Quinn.
Thanks, Trevor. So, as a lot of people are doing right now, we're going through a very large migration. We're taking an approach to really modernize a lot of our systems and utilizing AWS where it provides a benefit for us. We've worked with our teams internally. We've gone through a lot of different solutions across the board. And we've looked at the opportunity to integrate systems using more modern components and technology services from AWS. I think it's pretty much a no-brainer for everybody here, but it's something to be stated that when we're obviously a large bank, and having and utilizing cloud-based services has really been a big lift for us. So AWS is our predominant cloud provider. We're using a combination of the basic services such as compute and storage, as well as a lot of the platform services like SQS and RDS, Lambda, Redshift. Across the board, we're basically using them all. And we're going through and we're reducing our overall data center footprint with the support of the AWS migration services and some of the key partners that we work with on a daily basis. So a little background on Capital One. I know this is it's a little bit of an eye chart and a verbose slide, but I do want to highlight a couple things. So most people think cards when you think about Capital One. Our ads are everywhere for cards, but the bank gets lost in the shuffle a lot. We are the 8th largest US bank based on deposits. We've got major operations in 15 US cities as well as Canada and the UK. And then we've got 65 million customer accounts across all of our individual lines of business, and we've got 45,000 associates. We're also ranked number 112 on the Fortune 500 list. So focusing on the retail efforts, we're taking an approach to really go through an iterative improvement as we're going through the migration. The biggest challenge that I think a lot of people see is, there's lots of shiny new things that are in AWS. There's lots of great services that really provide a lot of benefit, but you have to take an iterative approach in order to do a migration. You can't go through the big bang. You can't go and change everything all at once. It just makes it too difficult. So we're going through and integrating modern components while being able to still maintain our existing architecture. We've spent many years building out the architecture, and we're pretty happy with most of it. So it's something that, as we're pushing in the different components, we want to make sure that we're utilizing as much as possible with maintaining the existing architecture. Obviously, providing access to existing applications is paramount when you're going through any kind of a transition like this. And we want to modernize as much as possible without really burdening our application development teams. As I go through this, you're gonna think that Trevor and I spent a good amount of time going back and forth on this, because it's a lot of things that I'm going to say here are going to ring true from what he said as well. So when we're looking at the areas of upgrade, using AWS specific services like SQS, and moving away from self-managing systems. I know there's still one guy that still wants to manage their systems, but our Q system is not one that we're looking to continue to manage. So. As well as being able to focus on the delivery and reliability of the systems. We're also looking at compute services. So as we move some of our legacy applications, we're moving to more modern compute services. And then being a bank, a big focus on resiliency and reliability for us. So leveraging things like auto scaling, the multi-data center environments that are inherent to AWS really make it a pretty simple task for us. So in our current queue system, we use JBoss as it is right now. We migrated to JBoss a few years back, so we're definitely no stranger to migrations in general, and specifically migrations with queuing. So with JBoss has been fairly stable for us, but with anything that's a linchpin and a pivotal system like queuing, you always have some kind of challenges to go with it. One of the biggest challenges for us is maintenance, whether it's on the software, the systems related to it, the databases. When maintenance is required, we routinely have to take downtime on the applications, and it would either be in a rolling fashion or in a full outage. So it really depended on how we went through and had our architecture. Some systems we were able to do it rolling, where we're able to swing the queues over to one of the other systems, take down half the cluster, and then move it over. But there's others. It was definitely a full outage. So when you look at maintenance, it can range from things like hung queues, high error counts in message reliability, patching on the operating system or the database, software upgrades, and maintenance. One thing that I found pretty funny that was advantageous that I received it literally 10 minutes before I walked in the door was that we got an end of life notice from JBoss on the current version that we're using, which is 5.4. So it literally the end of life date for it is today. So. Another pressure that we have is pushing a lot to our development teams whenever we have to do an upgrade to the JMS interaction in the client. The changes can range from a small change, but there's a lot of times that we've had to do some pretty heavy recodes in how the interaction goes. Accounting for, because we've got physical servers and databases, it causes a lot of challenges when we're accounting for growth, as well as aging hardware and software. With having things that are in a managed service perspective, we get it out of all of that, which is obviously a big lift for us. The other part is really having to administer multiple servers to account for resiliency. When you go through and have to build queue systems, it's one of those systems where you really you put it in place and then you walk away from it. You try not to think about it as much as possible, and you try to touch it as little as possible because it is so pivotal to a lot of the interactions. As it sits right now, we've got 10 servers in production. They're individual clusters for each individual instance. So it accounts for 5 clusters. That's in prod. We've got an additional 10 in DR for the exact sizing. And then we've got upwards of 35 lower environments that all have individual JBoss instances in them. So it's a significant amount of effort to really maintain the systems. The other thing you get when you've got individual clusters like that is you lose the visibility. So when you're accounting for having to individually monitor and then account for the growth of those applications, it requires constant care and feeding, and it's really something we want to take off our operations staff. So I want to walk through our existing application integration at a high level. This is a consistent model that we have for any of the systems that we have that are utilizing queuing. We obviously have a lot of other systems that utilize HTTP endpoints, so but this is traditionally talking about what we use from a queuing perspective. So if we walk through from left to right, if you start at bullet number 1, that's basically where the users interact with the front-end web app. Generally, these are front-ended with an ELB in AWS, or they're front-ended with an F5 on-prem. And then those users they're either going to be internal or external customers, and they're going to interact with the web front end. They will go through the process of one of our flows to submit the request to the front end. And then whether it's an update or a read, it then puts a message onto the request queue, which is at step 2. The customer's request can be multi-part or singular. We've got use cases for both. So if it's something where we have to fill multiple pieces of a form or multiple pieces of a flow, then they'll go through as multiple messages. And then those messages are returned sequentially or asynchronously, depending on how the front end is really putting them back together. The message goes to the general queue, and then it's stamped with an individual message ID, and that's held for processing for the middleware servers. And then at step 3, the middleware servers then pick up the message, process it downstream to either the customer databases, third-party applications, other services, and then once processing is complete, then they put it back on the reply queue, which is at step 5. The front-end web server then queries the reply queue. The reply queue queries are based on the message ID that was stamped as part of the initial request. And then once that's then queried and then pulled back, then it's then presented back to the customer in the web front end. And if it's an individual request, it comes back immediately. If it's a combined request, there's sometimes that we have to basically hold those messages in queue and then allow for them to then process sequentially. To give a little more detail around the complexity of the queue system, you could see the volume of queues as you look down that picture on the right-hand side. This is literally one single JBoss server and one application that has this amount of queues. We've got a lot of inter-server communication as well as intra-server communication. But you could really see the distinctness and complexity of the queues, and really why we have challenges with visibility. This is a pretty standard representation, so I don't think it's going to be really unique to a lot of situations or unique to us. But it's definitely something that we're looking to move away from. Because the sizing of the queues and the servers are static for each individual application, generally, when we look at how we size them, we've had to go on based on what we've done previously. We're standing up individual clusters. We're hoping that it's enough to be able to handle the volume, but not having any dynamic ability to be able to scale out. It makes it a challenge that when we've got low utilized systems, then we don't ever scale them in. When we've got high utilized systems, or we've got any type of a time where we get a surge, then we don't get any kind of a scale up on them either. And then because you can see all of these queues all the way down here, this is something that we have to do manually. So every one of these queues is built out manually. We put it out and we leave it as is. There's individual static property files that go along with it for every one of these. And then if you look at our DR scenario for these applications that are integrating with the queues, generally it's a slide in another set of property files, recycle Tomcat, and then it'll swing over to the other side. But that does take a downtime on the front end applications that are working through it. And then obviously something as small as a mistype in the naming, then it's going to cause issues that you don't necessarily see when you first stand it up. It may be something that you're chasing around for a while. So, and then the other thing that we have too is that, with a volume of queues like this and the number of applications that all have this exact same scenario, we use a lot of similar back-end systems. So one challenge we have with visibility is that if we see a spike in messages jumping up and we see error counts driving up on an individual application, it's a lot of times you can lead you down the path of thinking that there's an application issue with that server or that instance or the application itself, but not actually digging downstream, which is where a lot of times you'll find a problem, but you can't correlate that together with all the individual clusters. So when we went through the selection criteria, we looked at several options. Obviously, one was upgrading JBoss and putting that into AWS. We also looked at other open source vendors and cloud-based solution. We had many immutable conditions that we had to meet to make sure that we went through a seamless migration. Top of the list was really the simplified administration. With some of the challenges we've had in the past, we're really looking for a system that was easy to use, as well as having the features built in that we've had to cobble together in the past. We've had to custom write monitoring for a lot of the JMS queues as they sit now. We've used some of the other systems in the past that have their own monitoring built in, but there's never really a good solution to look at everything. The other part with SQS that's a great feature is dynamic queue creation. So when we've had to do this in the past, as I said, we go through and we have to basically build everything by hand. And when you're building it by hand, there's always going to be challenges that come in. Even if it's something that's a repeatable portion of it, you're still having to build the initial infrastructure by hand. With dynamic queue creation, obviously that simplifies a lot of the initial build out. Patching and updating of the systems is removed at this point. It gives us the ability to basically hand that time back to our operations staff to focus on other things besides queue administration and really maintaining the systems. Sizing the queues based on the usage pattern is huge. We've got some of our call center applications that aren't used at all. So they're done at 11 o'clock at night. They're not used until 7 in the morning, but we've got infrastructure that sits there idle all the time and is waiting for requests, but there's nothing going through it. And as well as things like being able to have surges. Black Friday is a good one. That we get a good amount of surges. Payday Fridays we get surges, and we don't have the ability to be able to scale those up right now. We also need to make sure that we have full encryption end to end. Obviously, as a bank, we need to make sure that we have full in-motion encryption. And with TLS 1.2, SQS meets the bill on that as well. Flexibility in the queue types is something that we always want to have the ability to be able to be flexible. You don't ever want to put something out there that you're never going to be able to have any changes on. So as Trevor stated earlier, FIFO is a new feature that can be utilized for many different types of scenarios. In our integrations, we're utilizing both Classic and FIFO. FIFO for the send, Classic for the receive. Mainly that's because we've got applications downstream with variable timings, and we want to be able to pick those messages out of order. So if we want to be able to do something like load a customer balance up before it goes into showing the last 50 transactions, then we want to make sure that we start to load those parts out of order. So continuing on with the selection criteria, we needed to ensure there was an easy integration with our application code. With small changes in our Java code now, we're able to update the client application so it could use the legacy JMS calls. Being a bank and a large enterprise, the focus on resiliency is huge for us. The multi-AZ deploys that you get that are inherent to AWS is a really big piece for us. It gets us the ability to be able to have resiliency without having to pre-build it. And moving to a serverless solution greatly simplifies the overall administration, allows our teams to really focus on the infrastructure and feature builds and not having to do queue administration. So I wanted to briefly touch on the positive interactions we have with Trevor and the SQS team, as well as the ProServe teams that we've been working with. Because we were participating in the private beta program, it gave us the ability to really work side by side with Trevor and the team. We were able to help develop some of the solutions and features that really not only suit our needs as well as benefit our infrastructure, but also provide an input to other customers that other customers will benefit from as well. We were also able to work with them to be able to solve some of our complex issues. One of our challenges is, as I stated, we go through and we query the message queues. So when an application makes a call, it goes and puts the message on the queue. We then query for it. It's based on it's time based on the application side. If we believe that the calls all downstream to a particular stored procedure are always going to take 4 seconds to make that call, and we query for that message at 10 seconds because we want to give a buffer time. Those individual queries then add in a considerable amount of time to be able to then pull that message back. So one of the things that we worked out was going to a thread-based model where we basically have an individual worker thread that's waiting with the application, and you get a one-to-one pairing with the response on the queue. So it's the response back from SQS that then triggers the next flow as opposed to having to do a query on the queue. But overall, it's been an extremely positive interaction, and I really do appreciate Trevor and the team for how much they've been working with us side by side. So I want to walk through the comparison of the existing queues versus a new queue integration. Looking at the existing queues, even though this is a high-level representation, I still think you can see the complexity here. This is 3 separate applications, so this isn't one contiguous application. This would be 3 separate applications where we've got a web front end down the left-hand side, we've got middleware down the other side, and then you can see the JBoss queues throughout the middle. We have to build those individual clusters and maintain that infrastructure then to be able to have that interaction. Going on to the new, you can see it's a little bit more simplified. With having SQS as being the service layer in between, it now gives us the ability to be able to utilize that service without having to. We have the same exact 3 web apps down the side. We have the same exact middleware clusters. And now they just talk with the service as opposed to having to have those individual JBoss clusters. One thing that's not depicted here is the queues, which I'll get into in the next slide. But that's really irrelevant to a contextual diagram. It's already complex enough when you look at the middle section of it. So let's talk through a detailed view. This is basically an expansion upon the previous diagram. Similar to the on-prem depiction, you could see that we take the path from the customer at step 1 to the web front end at step 2, and then instead of putting the messaging to the messages to JBoss, we're putting it to SQS at step 3. The middleware processes the messages downstream on the databases as well as the other systems, and then there's also inter-server interaction that you can see as those callouts in step 4 and 5. So if you look at that, you can see the middleware 01, 2, and 3 queue, as well as the individual queues all the way down. The pattern is intentionally similar to the previous diagram with one large stipulation. We've kept the application code reliability, application code in the interaction models, but added in a benefit from moving to SQS and getting a lot of the reliability, scalability, and easing the overall administration. You can see the call out for FIFO in the send queue, and the reply queues and the inter-server communication are classic. On the reply, there's a one-to-one correlation with the front-end server, so that's the reasoning for having the 3 individual queues going down. They're still built dynamically, but it's something that we build on startup of the front-end server, and this gives it a much smaller path for them to have to go through and deal with, as well as having keeping the messages segmented back to the front-end server. And then in the previous example of standing up static queues, all of these would have to be built by hand, but being able to go through and do it as a part of the scale up, it's definitely a huge benefit. And then the flexibility in the applications that use queuing, you don't get it, or you can't get this kind of flexibility without going to a service that really gives you the ability to dynamically build things out. So as a wrap up, I want to highlight a few key themes that we talked through. Migrating to SQS, we target the key benefits of moving to a more modern queue system with limited application development to do so. One of the biggest challenges you've had with a lot of this migration has really been getting the development teams on board. I don't think it's anything that anybody's not going to run into a challenge with. There's always time constraints that come in with any kind of a development effort, and making it as easy as possible was one of the big pieces to it. So that's why looking at SQS and being able to leverage a lot of the same code without having a lot of complex development was huge for us. Being able to utilize the queue systems similar to our other existing implementation, it gives us a lot of seamless migration. We're going down a path of building everything in parallel, side by side. So every piece of infrastructure, every application that we have that's on-prem that's going to be moving to AWS, we're building it side by side and having that infrastructure on the AWS side as well. It gives us a huge lift in resiliency and visibility. It's built into SQS. You don't have to go through and do the work that it takes to really get the resiliency, as well as being able to have things like CloudWatch to pull a lot of the metrics, look at the queues, be able to compare things, and then get a global view of it, as well as having a lot of the alerting built in too. And then really delivers a solution that's consistently maintained for us, without having to really do the sizing, the upgrading, or having the administration of it. So I think that's all I got. So thank you, and I'll hand it back to Trevor to finish up a couple of final thoughts.
Great, thanks very much, Quinn. It's a pretty exciting project, and we really enjoyed working with you on that. So just as a summary and to wrap up, and then we have a few minutes for questions. So just to close, messaging is a very common requirement in enterprise architectures, and that was pretty obvious with how many people put up their hands when I asked that question earlier. And it's becoming, I think, even more common as we see more and more services moving to like a microservices model. And there's much more intercommunication needed between components. The managed messaging services, as you saw from Quinn's talk, really help you remove that overhead and administrative pain. So it's really something that customers love, and we see more and more customers looking at moving from on-prem middleware to the cloud. And particularly with the new FIFO queues, we talked to so many customers that they were stuck with on-prem middleware just because they didn't have those ordered queues available in SQS. So we're pretty excited about the FIFO queues, and we think that's really going to enable a lot more use cases to move to managed messaging services. And last, we are investing in more key enterprise messaging features. Can't tell you just yet what those are, but stay tuned. We're going to have lots of things coming out in the next few months and the next year, and hopefully we'll be up here at reInvent next year telling you about some of those as well. So with that, thanks everyone for coming, and Quinn and I are open to any questions you might have.